All right, let's compute the character table for D5. Presented here. Actually, let me start by computing the character table for the cyclic subgroup of order 5. And here's what that looked like. Of course, all the representations are one-dimensional, so I'm just writing down all the homomorphisms to the complex units. So what I want to do is I want to take all these and induce them up to D5. So there are the conjugacy classes in D5. So inducing up from a subgroup of index 2 doubles the dimension. So it's easy to calculate it on J because none of the conjugates of J are in the subgroup at all. That's because it's a normal subgroup. So anything not in the subgroup has nothing conjugate to anything in the subgroup. That's typical when you induce from a normal subgroup. And then there's the general computation of the induced characters in terms of these numbers alpha and beta, which are sums of the fifth roots of unity in that way. Notice that these are actually going to be real numbers. So you can calculate that if you take the inner product of the induced character with itself, you'll get 1 if k is 2, 3, 4, or 5. So those are all irreducible representations. You really only get 2 new ones. The other one is not irreducible, as you can easily check. It's a sum of 2 one-dimensional representations. So using this, we can fill in the full character table for D5. There are the 2 one-dimensional representations. And there are those 2 new ones, those induced representations, which turned out to be irreducible.